What if one of your body's most important appetite control systems begins inside your gut? Not inside a supplement bottle, not inside a gym, and not even inside your brain. Every time you eat, special cells in your intestine release a hormone called GLP-1. It helps your body respond to food, supports insulin release, and sends signals that may help you feel satisfied. That name probably sounds familiar because GLP-1 medicines have completely changed the conversation around diabetes and weight loss. But here is what most people do not know. Your body was producing its own GLP-1 long before these medicines existed. And the bacteria living inside your gut may influence the signals that tell those GLP-1 producing cells when to respond. So does this mean that a probiotic, prebiotic, or special food can work like a weight loss injection? No, and that difference is extremely important, but it also does not mean the gut connection is meaningless. Researchers are discovering that gut bacteria, blood sugar, appetite hormones, and the intestinal barrier may be communicating with each other more closely than we once realized. The surprising part is that strengthening one part of this system does not always lead to dramatic weight loss. Sometimes blood sugar improves without weight changing. Sometimes a gut barrier marker improves while body fat stays exactly the same. And sometimes a study looks exciting until a larger trial gives a much more complicated answer. That is the story we are about to uncover. Think about the last time you tried to lose weight. You may have counted calories, removed certain foods, or forced yourself to ignore hunger. That approach can work for some people. But hunger is not simply a lack of willpower. Your brain is constantly receiving information from your stomach, intestine, fat tissue, pancreas, and bloodstream. Those systems report whether food has arrived, how quickly blood sugar is rising, how much stored energy is available, and whether you may need to eat again. GLP-1 is one part of that communication network. It is released mainly by specialized intestinal cells after nutrients reach the gut. It can support glucose-dependent insulin release, slow movement of food through the stomach, and contribute to fullness. But there is another player, the gut microbiome. This is the community of bacteria and other microorganisms living mainly in your large intestine. Some of these organisms break down fibers that you cannot fully digest. During that process, they produce small compounds known as short-chain fatty acids. Those compounds may communicate with intestinal cells, immune cells, and appetite-related pathways. But wait until you hear this. Simply producing more of one gut compound does not guarantee that you will automatically eat less or lose weight. Human biology is rarely that simple. The biggest myth is that anything that supports natural GLP-1 must work like semaglutide or another prescription GLP-1 medicine. It does not. Your natural GLP-1 is released in pulses after food arrives, and the active hormone is normally broken down quickly. Prescription GLP-1 receptor agonists are designed to activate the GLP-1 receptor for much longer. Their strength, dose, and duration are fundamentally different from the small hormonal changes that may follow a meal, a fiber supplement, or a probiotic. So when a product calls itself nature's Ozempic, that is a major warning sign. A yogurt, bacterial strain, or fiber powder should not be presented as an equivalent replacement for evidence-based obesity or diabetes treatment. Here is the second myth. If someone has difficulty losing weight, they must have a leaky gut. Intestinal permeability is real. Your gut lining must allow nutrients through while helping keep unwanted material inside the intestinal space. Researchers can measure aspects of this barrier using specialized tests and biomarkers, but leaky gut is often used online as a vague explanation for fatigue, weight gain, bloating, skin problems, and almost everything else. Those symptoms alone cannot prove that the intestinal barrier is the cause, and this completely changes the story. The gut barrier may be one contributor to metabolic health, but it is not a single master switch controlling every kilogram of body weight. What makes the gut GLP-1 connection different? Most weight loss discussions focus only on calories entering the body and calories leaving it. That equation matters, but it does not describe the signals influencing how hungry you feel, which foods you choose, or how your body handles glucose after a meal. The gut GLP-1 connection adds a second layer. First, food reaches your digestive system. Second, nutrients and microbial products interact with intestinal cells. Third, hormones such as GLP-1 and peptide YY can carry information toward the pancreas and brain. Fourth, insulin, blood sugar, stomach emptying, and appetite may respond. At the same time, the intestinal barrier and immune system are monitoring what is happening at the gut wall. The interesting part is that the microbiome may affect several parts of this system at once. It may influence fermentation, bile acid metabolism, inflammation, intestinal permeability, and hormonal signaling. But each bacterial strain has different properties. Even two probiotics with nearly identical names can produce different results. That is why the question, do probiotics increase GLP-1, is too broad. A better question is, which exact strain, at which dose, in which group of people, for how long, and compared with what? Once you ask the question that way, the scientific evidence becomes much more useful and much less sensational. Imagine your intestine as a long communication center. Along the intestinal wall are hormone-producing cells called enteroendocrine cells. That simply means intestinal cells that release hormones. Some of these are known as L cells. When nutrients arrive, L cells can release GLP-1. Protein, carbohydrate, and fat can all contribute to this response, although the pattern depends on the meal and the individual. Farther down the digestive tract, gut bacteria meet fibers and resistant starches that escape digestion higher in the intestine. They ferment these carbohydrates and produce short-chain fatty acids, including acetate, propionate, and butyrate. These compounds are not magic fat burners. However, they can act as chemical messengers. In laboratory and animal research, they interact with receptors involved in GLP-1 and peptide YY secretion. Human trials suggest that targeted fermentation products can sometimes affect appetite hormones, energy intake, or weight-related outcomes, but the results depend heavily on the fiber, delivery method, and study population. Gut bacteria also transform bile acids. Bile acids help digest fat, but they also act as signaling molecules. Some bile acid signals may influence glucose metabolism and GLP-1 release. Then there is the gut barrier. A healthy intestinal lining is protected by mucus, tightly connected cells, immune defenses, and beneficial microbial activity. When this system is disturbed, more bacterial material may cross or signal through the barrier, potentially contributing to low-grade inflammation. Low-grade means inflammation that is not as obvious as an infection but may remain active over time. Inflammation can interfere with insulin signaling. When cells become less responsive to insulin, the pancreas may need to produce more insulin to manage the same amount of glucose. But here is the key point. These pathways form a network. Improving a barrier marker does not prove that weight loss will follow. Increasing GLP-1 briefly does not guarantee lower calorie intake. And changing the microbiome does not always change metabolism. That is exactly why human trials matter. Let us begin with a study that did not use a probiotic. Researchers wanted to deliver propionate directly to the large intestine. Propionate is one of the short-chain fatty acids produced when microbes ferment certain fibers. They created a specialized ingredient called Inulin-propionate ester. In one part of the research, delivering propionate to the colon increased GLP-1 and peptide YY and reduced food intake during an acute test. Then researchers followed 60 adults with overweight for 24 weeks. The group receiving 10 grams of Inulin-propionate ester was less likely to gain significant weight. They also showed reductions in abdominal fat distribution and liver fat compared with the control group. That sounds impressive, but do not miss an important detail. This was a specialized delivery ingredient. It does not prove that any generic inulin supplement will produce the same result. Now consider a probiotic study involving Limosilactobacillus reuteri. Researchers studied 21 glucose-tolerant adults in a prospective, randomized, double-blind trial. Compared with placebo, the strain increased glucose-stimulated GLP-1 release by approximately 76%. Insulin and C-peptide secretion also increased, but insulin sensitivity and body fat distribution did not significantly improve. In other words, the hormonal signal changed, but the outcomes people usually care about, better insulin sensitivity or less body fat, did not automatically follow. This was an early proof of concept study, not proof of a weight loss treatment. Next comes one of the most discussed gut bacteria in metabolic health, Akkermansia muciniphila. In a 2019 pilot study, 40 adults with overweight or obesity and insulin resistance were enrolled, and 32 completed the trial. Participants received live Akkermansia, pasteurized Akkermansia, or placebo for 3 months. Compared with placebo, the pasteurized form improved a measure of insulin sensitivity and reduced fasting insulin and total cholesterol. Body weight fell by about 2.3 kilograms compared with placebo, but that weight difference did not reach standard statistical significance. This was encouraging, but it was a small exploratory study. It could not prove that the supplement reliably causes weight loss in the general population. Then, in June 2026, researchers published a much larger multi-center trial involving 142 adults with metabolic syndrome. Participants received 30 billion pasteurized Akkermansia muciniphila each day or placebo. The primary outcome, whole-body insulin sensitivity after 4 months, did not significantly differ between the groups. However, exploratory analyses found possible benefits in certain subgroups, especially participants who began the study with low levels of Akkermansia in their gut. In those participants, researchers observed improvements in insulin sensitivity measures and GLP-1 response, together with a reduction in trunk fat. Body weight reduction showed a borderline result. This may point toward personalized microbiome treatment, but subgroup findings are less certain than a successful primary outcome and must be confirmed in future trials. The study also reported important industry relationships involving several authors, which does not invalidate the research but should be considered when interpreting it. Now let us move from weight loss to type 2 diabetes. A 2025 randomized double-blind trial included 120 adults with type 2 diabetes. They received either Bifidobacterium animalis subspecies lactis MN-GUP, the same probiotic combined with Galactooligosaccharides, or placebo for 12 weeks. The combination is called a synbiotic because it contains a probiotic plus a prebiotic. The synbiotic group reduced fasting blood glucose more than placebo, with an average between-group difference of 0.69 millimoles per liter. The synbiotic group also showed changes in GLP-1, bile acids, inflammation, and the microbiome. However, most other glucose measurements were not significantly better than placebo in the direct between-group comparisons. Practical meaning? This specific synbiotic may provide additional glucose support for some people with diabetes, but it should not replace diabetes medication, nutrition care, or medical monitoring. What about the gut barrier? A 2026 trial studied 60 adults with excess body fat. Participants received Bifidobacterium bifidum or placebo for 8 weeks. The probiotic did not significantly reduce BMI, body fat percentage, or the study's primary inflammation outcome, but it did reduce fasting insulin, TNF-alpha, and circulating zonulin, a research marker connected with intestinal permeability. Again, the result was not probiotic causes weight loss. The more accurate message was that certain metabolic and barrier-related markers improved even though body composition did not. A separate trial in adults with obesity found that specific Bifidobacterium strains and Galactooligosaccharides improved laboratory markers of colonic permeability after 3 weeks. Surprisingly, combining the probiotic and prebiotic did not create a clear synergistic benefit. A synbiotic was not automatically better just because it contained more components. When researchers combine many trials, the picture remains promising but modest. A 2024 meta-analysis evaluated 41 randomized trials involving 2,991 people with diabetes. Probiotics and synbiotics produced statistically significant improvements in HbA1c, fasting glucose, and insulin. But the effects differed considerably across strains, countries, and study designs. And a systematic review of 24 studies involving 1,587 participants concluded that probiotics had minimal overall effects on appetite-related hormones in people with overweight or obesity. So yes, positive results exist. But the evidence does not support the idea that an ordinary probiotic capsule consistently creates drug-level appetite suppression or major weight loss. The people most likely to benefit are not necessarily those searching for the strongest, fat-burning probiotic. A gut support strategy may be more useful for someone whose overall diet is low in fiber, plant variety, and fermented foods. It may also be relevant for adults with metabolic risk factors who are already following a medical plan for prediabetes or type 2 diabetes. Someone with constipation may benefit from carefully increasing soluble fiber, although the right type and dose matter. People taking prescribed GLP-1 medicines may also need to pay attention to protein, fluid, fiber, and bowel regularity because reduced food intake and digestive side effects can make nutritional quality more difficult to maintain. But the surprising part is that the person who benefits from one strain may not respond to another. The 2026 Akkermansia trial suggests that baseline microbiome composition may influence response. Participants with low initial Akkermansia levels appeared more likely to benefit in exploratory analyses. This does not yet mean that a home microbiome test can choose the perfect supplement for you. It means researchers are beginning to identify why one person may respond while another notices nothing. Who should be careful? First, anyone taking medication for diabetes should not add supplements and then change medication doses without speaking to a qualified clinician. Even when a nutritional product has only a modest effect, glucose changes matter when they occur alongside insulin or glucose-lowering medication. Second, people who are severely immunocompromised, critically ill, or living with a central venous catheter should obtain medical advice before using live microbial supplements. Most probiotics are well tolerated by healthy adults, but natural does not mean risk-free for every person. Third, increase fermentable fiber slowly. A sudden large dose of inulin, GOS, or resistant starch may cause gas, cramping, loose stools, or worsening bloating. This does not necessarily mean the fiber is damaging your gut. It may simply mean the dose increased faster than your digestive system could tolerate. Finally, do not blame every digestive or weight-related symptom on the microbiome. Blood in the stool, persistent vomiting, severe abdominal pain, unexplained weight loss, or major changes in bowel habits need proper medical assessment. A supplement should never delay the investigation of a serious symptom. The most common mistakes. Mistake number 1 is buying a probiotic because the front label says 50 billion. A higher bacterial count does not prove that the product contains the right strain for your goal. Mistake number 2 is ignoring the strain code. Lactobacillus reuteri SD5865 is not automatically interchangeable with every other L. reuteri strain. The strain code works almost like a model number. It helps connect the product to the actual research. Mistake number 3 is expecting visible weight loss in 1 week. Most microbiome trials last several weeks or months, and even successful studies generally report modest effects. Mistake number 4 is changing everything at once. You begin a probiotic, add 3 fiber powders, stop sugar, start fasting, and double your exercise. Then you cannot tell which change helped or which caused your stomach symptoms. Mistake number 5 is treating a supplement as permission to ignore the rest of your diet. A capsule cannot replace legumes, vegetables, fruit, whole grains, adequate protein, sleep, and regular movement. And the biggest mistake? Choosing a product marketed as a natural replacement for prescription GLP-1 treatment. That claim goes far beyond the current human evidence. How to choose the right product. Begin with your real goal. Are you trying to improve bowel regularity, increase fiber intake, support glucose management, or test a strain studied for a specific metabolic outcome? Those are different goals. For a probiotic, look for the complete genus, species, and strain. For example, the label should give more information than simply Bifidobacterium blend. Look for a daily dose that is reasonably connected to human research on that exact strain. Check whether the stated bacterial count is guaranteed through the end of shelf life rather than only at manufacturing. Choose manufacturers that provide clear storage instructions, batch testing, and contact information. Avoid products that hide every strain inside a proprietary blend. For a prebiotic, identify the actual ingredient and amount. Inulin, Galactooligosaccharides, partially hydrolyzed guar gum, and resistant starch are not identical. Start below the full serving when appropriate and increase gradually. For a synbiotic, do not assume that adding bacteria and fiber together must create a superior result. Human research has sometimes found benefit from the separate components without additional synergy when combined. Most importantly, judge the product by the claim it makes. Supports digestive health is very different from melts belly fat or works like a GLP-1 injection. The more dramatic the promise, the more evidence you should demand. Frequently asked questions. Can probiotics increase GLP-1? Certain strains have increased GLP-1 responses in small human trials. The reuteri SD5865 study is one example. However, broader reviews suggest that probiotic effects on appetite-related hormones are inconsistent and often small. The result from one strain cannot be applied to every probiotic. Can food or supplements work like semaglutide? No food or probiotic has been shown to reproduce the potency, duration, and reliable clinical effects of prescription GLP-1 receptor agonists. Foods can support your natural appetite and glucose systems, but that is not the same as pharmacological receptor activation. Which foods support microbial fermentation? Legumes, oats, barley, vegetables, fruit, nuts, seeds, and resistant starch foods can provide fermentable carbohydrates. Examples of resistant starch foods may include cooked and cooled potatoes, rice, or certain grains. Increase these foods gradually, especially if your current fiber intake is low. Are fermented foods the same as probiotics? Not always. Yogurt or kefir may contain live microorganisms, but a fermented food is not automatically a clinically tested probiotic. To call a microorganism a probiotic in the scientific sense, its health effect should be connected to an identified strain and adequate amount. How long should I test a supplement? Many metabolic trials last around 8 to 12 weeks, while some continue for several months. That does not mean everyone must take a product for exactly that period. Track your original goal, digestive tolerance, and measurable outcomes rather than relying on vague feelings. Does improving the gut barrier cause weight loss? Not necessarily. The 2026 BGN4 trial improved zonulin, fasting insulin, and TNF-alpha, but did not significantly change BMI or body fat percentage. Barrier-related changes may be valuable, but they do not automatically translate into weight loss. Should I buy a home microbiome test? Consumer microbiome tests can describe some of the organisms found in a stool sample, but science cannot yet use most of these reports to prescribe a guaranteed weight loss probiotic. Future testing may become more useful. Right now, the interpretation is often more confident than the clinical evidence. Can I combine probiotics with a GLP-1 medicine? Many people consume probiotic foods while using these medicines, but a new supplement should be discussed with your clinician when you have diabetes, significant digestive symptoms, or multiple medications. Do not stop or reduce a prescribed medicine because a supplement claims to raise GLP-1 naturally. The next stage of microbiome science may not be about finding one universal weight loss bacterium. It may be about finding responders. Researchers need to discover whether baseline Akkermansia, Bifidobacterium, microbial genes, dietary habits, or bile acid patterns can predict who will benefit from a particular intervention. We also need larger trials using validated measurements of intestinal permeability rather than relying on a single blood marker. Future studies must compare strains directly, report negative outcomes clearly, and continue long enough to show whether benefits survive after supplementation ends. Another major question is how nutrition and the microbiome interact with prescription GLP-1 treatment. Could fiber help support bowel regularity and diet quality? Could certain microbial patterns predict side effects or weight regain? These questions are important, but the evidence is still emerging. The honest answer is not that the microbiome has failed. It is that we are moving from exciting theories toward the much harder task of discovering what reliably works in real people. Here is what you should remember. Your intestine naturally produces GLP-1 after you eat. Gut bacteria may influence that system through fiber fermentation, short-chain fatty acids, bile acids, immune signaling, and the intestinal barrier. Human trials show that some targeted fibers, probiotics, and synbiotics can affect GLP-1, insulin, fasting glucose, inflammation, or barrier-related markers. But the effects are strain-specific and usually modest. A change in GLP-1 does not automatically mean weight loss. A stronger gut barrier marker does not prove that body fat will fall. And a product that works in a small subgroup may not work in everyone. The best supported strategy is not to chase a miracle capsule. Build the foundation first. Eat a wider range of fiber-rich plants. Include adequate protein. Move regularly. Protect your sleep. Increase fermentable fiber slowly. And when using a supplement, choose a clearly identified ingredient or strain linked to a relevant human study. Most importantly, never replace prescribed diabetes or obesity treatment with a product simply because its advertisement mentions GLP-1. Science supports curiosity. It does not support exaggeration. But one question remains. Why did pasteurized or non-living Akkermansia muciniphila sometimes perform better than the live bacteria? That result challenges the idea that every effective probiotic must be alive. In the next video, we will follow Akkermansia from the mucus layer of the intestine into the newest human trials and reveal why your starting microbiome may decide whether you respond at all. Watch that video next because it completely changes how you should evaluate the new generation of gut health supplements. If you want to understand how your body really works and the benefits of probiotics, subscribe to this channel, because we turn complex scientific topics into simple and powerful information that you can actually use. And if you found this helpful, share it with someone who cares about their health.